Welcome, everyone, to the Information's TITV. My name is Akash Pasricha. It is Thursday, June 25th. Today on the show, the Information has exclusive reporting that Google is reorganizing its recently launched strike team working on AI coding models. We'll dig into those details shortly. We'll then get some analysis on Micron and Cerebras' quarterly results, OpenAI's new Jalapeno chip, and Qualcomm's acquisition. Plus, a look at the growing rift currently dividing the physical AI space. And Odyssey, a new AI lab focused on world models, has raised $310 million at a $1.45 billion valuation. We will look at what is driving those massive funding rounds. It's going to be a great show, so let's get right on into it. Google shares have suffered a big drop over the past few days after two of its most senior researchers left the company for rival AI labs. Now, the Information has exclusive reporting that the company is revamping the team that is working on its AI coding models to make it more competitive. My colleague Aaron Wu, who covers OpenAI and Google, reported that story. And for more context, I want to bring on Jason Dean, our San Francisco bureau chief, to help us break it all down. Jason, welcome back to the show. It's great to have you here.
Thanks. Good to be here.
Okay, so let's just back up a bit. Google loses two of its star researchers. Noam Shazir goes to OpenAI. John Jumper goes to Anthropic. We didn't have a great sense at the time, at the time that Noam left, at least, why it was he may have made the jump. What do we know now about these two departures?
There's still quite a bit of mystery around these, but Aaron has learned a couple of interesting things in her reporting. First of all, Shazir told people before he left that Google had shifted away or really kind of combined the computing resources for his project that he was working on with that of other teams, and so basically diminished his access to compute. It's not exactly clear how that, shaped his thinking, but obviously, something very important. And he's been doing work. Shazir, of course, is one of the co-authors of the seminal AI paper on transformers that kind of gave birth to the current AI boom. He's been doing work on sort of new architectures for AI beyond transformers. So the access to compute obviously is a big issue inside Google, and something that he flagged to people before he left. The other thing is that Google's CTO, in announcing his departure internally, said that it was very sudden. So, clearly there was some abrupt rupture here. The exact linkage isn't clear, but this was something that happened suddenly and happened after this compute issue.
Right. Okay. So Google is left to pick up the pieces, I guess, of these two departures. And I should say that, they lost one Nobel Prize winner, but they still, Demis is also a Nobel Prize winner, right? So it's,
they're down 50% on Nobel.
Yeah, in some sense, can't stack the whole team in some cases. But okay, so Google is left to pick up the pieces. So what did we learn then about how they are reorganizing themselves to address this moment?
Yeah, so some of these, this is sort of an evolution of things that have been in the works in recent months, going back to when Aaron scooped the creation of what they call a code strike team in Google to accelerate its efforts to build AI coding tools. And what they're doing now is that's only months old, but they're restructuring it and expanding its remit. And making it a more permanent thing. Part of what they're doing is to try to make it easier for them they're changing the way that they do training of Google's models to make it easier for them to enhance the capabilities, not only in coding, but in other sort of white collar applications, which is something we're seeing at the rivals, Anthropic and OpenAI, which are kind of further ahead in this area of enterprise AI than Google is. Both Claude Code and Codex products are being expanded into other areas adjacent to coding, trying to develop the same success that Anthropic's had with coding in other areas. So Google's change in the way it's training these models and the expansion of the remit of this strike team, making of it permanent, is designed to sort of enhance the ability to improve those products where Google's been a laggard.
Now, one of the things that Aaron focused on in the story is this concept of mid-training. What is mid-training, and why is that so important right now?
Yeah, I mean, this stuff can kind of make your head spin a little bit, all the jargon. But we tend to group the creation of these models into pre-training and post-training. And pre-training, where you're sort of building the basic intelligence, you're building the model, it's learning. And post-training, we're kind of adapting it to specific functions. This is a disaggregation of that. So you're taking that learning process and enabling the models to become more specialized in what they can do before you get into the post-training process of adapting, like how they interact with users, the model's behavior. And again, this is the goal seems to be to try to enable the models to be better at specific functions like coding, et cetera, before you get into the behavior part, just the underlying intelligence to be better before you get into the behavior aspect of it.
Okay, so let's go back to the strike team that Google has established. Aaron had reported that this team it came together a couple months ago. They've now changed the organization of it a bit. Do we know how big the team is? Who's in it? How much power they have internally in the organization? Like, is this kind of like the equivalent to? Um, I don't know. I'm thinking at Meta. Like Meta has the super intelligence group. Like, is this just a coding specific group, or is this the group?
I think their remit is expanding now. It's been a pretty important team inside this, and we know that in part because not only is it's led by a DeepMind veteran engineer who's been there for 8 years, but has also had the involvement of the DeepMind CTO as well as Google co-founder Sergey Brin. So this has been something that's been very important for the company. And I think, though we haven't really seen the tangible results yet in terms of them closing the gap in a meaningful way with their competitors on things like coding tools, the fact that they're sort of solidifying this team and making it more permanent and expanding its areas of focus suggests that they think that it's working.
Yeah. Why do you think that is though that we haven't seen results in coding? I mean, Google has excelled at seemingly every other part of AI, including chips now. Coding seems like I don't know, you're a software like how did you miss the boat on coding? Why do we think they haven't been able to crack that?
Well, I think, part of it is they were late to it, and kind of everybody was late to it except for Anthropic, right? Anthropic figured this out before others, whether that was through some great visionary foresight or sort of they stumbled into it. There could be a debate, but they were first to it. That's been the killer app in the enterprise in terms of generating revenue. OpenAI is trying to be a fast follow there. Google's trying to be a fast follow also, perhaps not as fast. I think also what Aaron's reporting shows is that there was an initial faith that if you build the underlying model, the coding capabilities will come. And it's clearly not that simple. You need to do more than just make a really smart model that can do everything. You really need to focus on enabling those capabilities, and that's part of what they're trying to do now.
Right. Last question for you, Jason. The latest Gemini model, we are expecting it. I think Aaron had reported we were expecting it in June. It hasn't been released yet. Do we have any updates on that?
Yeah, I mean, there's still a few days left in June, which is what they said. This is Gemini 3.5 Pro. They came out with Flash at Google I/O last month and said that the Pro version would be the sort of flagship model would be available in June. Not here yet. It's looking much more like it's going to be July. I mean, the exact timing, if it slips into July, perhaps not the biggest deal. I think the bigger question is, will it,
Be
what
better.
will it be, and will it be
It
that much better? Yeah.
right, and I mean, early in the I guess, based on Aaron's reporting, it seems like that still is not going to rise to the level of Fable yet.
Right, right. Which, maybe that's a good thing. Maybe that means it won't be sort of banned or restricted by the administration.
Yeah, I mean, Anthropic is still quite loud about it. You go on Claude, I mean, they still have the bar there, as long as they have that rule in place, they are very loud about the fact that, look, it's not our fault.
They're getting marketing mileage out of it, if nothing else.
Yeah, yeah. All right. Well, Jason, I want to thank you for coming on. That is Jason Dean, our San Francisco bureau chief here at The Information. Shares of Micron are jumping after the chipmaker more than quadrupled its revenue in the latest quarter. The results offer some relief for the semiconductor sector after Cerebras flagged shrinking margins earlier this week in its first report since its IPO. I want to bring on Matt Bryson, Managing Director of Equity Research at Wedbush, and Mustafa Neemuchwala, partner at New Enterprise Associates, to unpack both of those results. Welcome to the both of you. It's great to have you here. Matt, I want to start with you. What did you make of Micron's very strong report last night?
I think the most interesting piece, beside the beat and raise again, was the granularity they were able to give around these longer term contracts that they've set up, where you're looking at, it feels like roughly half the annual value of their output to these customers as being guaranteed, or a cash payment that is forfeit if the customer breaks the contract. And that sets up a level of certainty for Micron and I think the industry that we haven't seen before. I think that largely is what the stock's reacting to, the idea that instead of trying to pick the end of the cycle, now we've got a longer term guaranteed cash flow, if you will, and how do you value that within this industry that used to be completely cyclical?
And is that all a result of the memory chip shortage, or what's the root cause that they were able to give that granularity?
Oh, I think it's certainly how tape memory has become. That they
Yeah,
just have more leverage than they ever had before.
right. Mustafa, what stood out to you?
I would say I think the biggest question in memory for the last couple of quarters has been, when does the deceleration start to show up? I think the cyclicality that we have all been talking about implicitly implies that there will come a quarter, or there will come a quarter sometime far out, because markets look forward, where we'll have the deceleration start to show up. And right now, because of the SCAs, the strategic customer agreements that Matt was just referencing, we know that visibility is not until perhaps 28. And that's really what we're talking about right now, is when does that cyclicality, if it ever comes back, start to show up? And so far, they're sold out through 27. Margins are double what they were at prior peaks. And so even if the cyclicality concept is there, I think one of the other things we've all been talking about is how much cash do you get back uh, from an earnings perspective. And if you look at, Micron's probably relatively more expensive, but you look at Hynix, you look at Kioxia in Japan, a lot of people's math will tell them by the end of 28, you get the entire enterprise value back in just the cash flow these companies generate.
So, Matt, one thing that I was curious about is when you look at the multiple for Micron and memory chip companies, broadly speaking, compared to some of the other chip companies, it's still, I mean, I think it was trading at something like seven times last I checked this morning, and that was forward sales. That is lower than the GPU companies. And so, my question is, do you see those multiples converging at some point?
I mean, that's exactly what investors are talking about, right? If I'm willing to pay 30, 40, 50 times for some of these accelerator names, then why am I not willing to pay 10 times, 11 times for a Micron if I believe that there's earning stability out there? Now, do I ever think Micron's going to get a 50x multiple? I don't. I think at the end of the day that eventually, because you bring on these fabs in big chunks, because customers are somewhat opaque, you end up with oversupply at some point, and so you lose leverage. But at the same time, I think it's a question worth asking. Again, why wouldn't you be willing to pay 11 times, 12 times for Micron if you're willing to pay 40 times for AMD?
So, Mustafa, Matt is saying that the memory multiples are likely to come up a bit. The other way of thinking about it is maybe the GPU multiples come down. What do you think is more likely here?
I would say I think most people would tell you right now that NVIDIA is cheap and NVIDIA has been cheap. We're talking about, depending on your numbers, 10, 12, 15 times gap PE. So it's tough to see, necessarily the NVIDIA multiple coming down, unless, of course, the metric comes down. I think the way I would pose this question is, right now we're talking about 40 to 50% of CapEx, of hyperscaler CapEx going to memory. I think the question we have to ask ourselves is, what do we think the art of the possible on that can be? And then I think you obviously talk a lot about the cyclicality, about the cash certainty, about the margin profile, and then you do the math backwards. Another way of thinking about it also is from a market cap perspective. If we were to get Micron and Hynix and Samsung and Kioxia and WDC, Western Digital, the drives, the memory, folks that are underlying the same macro trend, how much in implied earnings power, and then as a result, implied market cap are we talking about? I mean, you pretty quickly get to a number that's much larger than all of their customers combined. And I think that's where you get into this whole question of, where does value accrue? And obviously, this is the bottleneck today, but in the arc of time, do we think the memory companies are going to be larger than all the hyperscalers? Well, I think that would lead to an interesting question of how long that constraint lasts. And as Matt mentioned, as we all talk about, fab capacity will come online. The question is when, and the question is, what does supply-demand imbalance at that point in time look like?
Right. Matt, I want to go to Cerebras. They pointed to margins that they said were misunderstood. They said that's what Andrew Feldman said on CNBC. What was your read on the margins, which were narrower for the full year in the forecast?
Yeah, Cerebras, I think during the IPO proceedings was pretty open about the fact that as OpenAI comes on, it's a drag on gross margins. I think there's two things going on there. One, very large customer, so they're going to get somewhat favorable terms. But then two, because it takes time to bring data center capacity up, for them to satisfy the first tranche of that agreement, they have to go and rent back capacity that they've sold to another customer, and that's just more expensive than servicing OpenAI out of their own capacity. So I think that's what you're seeing. I honestly don't think that's necessarily what surprised investors. And if anything, the actual gross margin deterioration isn't quite as bad as I think people had modeled. Rather, I think what is really weighing on the stock is it has this strange lockup configuration where shares get unlocked after that first earnings period. So the way I look at it, there's just more stock available, and that's probably the greater reason the stock's down. I mean, honestly, what happens this year doesn't matter that much. For Cerebras, you own Cerebras because you think they are going to be one of the major players in serving the AI compute market, and that they'll have 5, 10, 15% share, whatever the number is. And if that scenario plays out, the company's a whole lot more valuable than it is right now.
Right. Mustafa, I'm curious, you invest in early stage companies, and chip companies are certainly part of the pool of companies that you consider. I mean, is the strategy right now that if I'm a chip company, there's so much demand, and look, there are dozens, hundreds of these chip companies that are starting out. Um, it's not really a question of can you take market share away because the market is growing so fast. So I guess my question is, um, how do you even decipher how do you distinguish between these chip companies when does it really matter which one is better if the market is growing so fast?
I mean, let's be super real. I think the biggest question for any customer is, when can you get me those chips? If you can get me those chips today, I'll buy whatever that chip is, whatever the perf per watt is, whatever the packaging constraints are, et cetera. But that, of course, is impacted by architecture. And so if you're doing the wafer scale approach, you don't have to rely on HBM, you don't have to rely on advanced packaging, you don't have to rely on CoWoS, you might not have to even rely on the leading edge TSMC node. Those three things, specifically leading edge node, CoWoS, and HBM, are constraints or bottlenecks. So the less bottlenecks you have, even if that reduces performance, the faster you can get your chips out. On the flip side, everyone's obviously ramping capacity and thinking about architectures and doing a lot of the constraint optimization around the same time. And obviously, we'll talk about Jalapeno in a second. But if we're talking about 27, 28,
we have a lot of chip capacity coming online. That's where I think it becomes more of a question of what you said, which is where do you slot in? And I think all of us have been talking about pre-filled decode, the disaggregation of inference. You can have these inference-focused chips that can handle more of the speed and the kind of fast, essentially interactivity that you need to have with these models on inference time. But you can separate how KB caches are dealt with, where HBM can matter. Now, obviously, it's interesting because if you take out the bottlenecks, a lot of people would still like to have all of those nice to haves, advanced packaging, CoWoS, of course, HBM and fast memory, because you can handle a lot more scale in these model sizes as well. And so I think really it's about timing and then performance per watt, of course, in the US, and externally performance per watt matters less because energy is less of a constraint. So that's the other dimension as well. It's really all constraint optimization based, paired with what you said around the kind of market itself.
Matt, what do you think of this question?
I think that chip quality still matters. And to preface this, I'm a history major, so I don't design chips, I don't choose chips, but I look at Microsoft, I look at Meta. They've been working on custom ASICs for 2-3 years now, and you're not seeing a lot of volume. So just having a chip was good enough. I think you would have seen both Microsoft and Meta ramp their efforts, and we haven't. With Cerebras, the thing that stands out to me is, look, they want to deal with OpenAI, they want to deal with Amazon. You don't see the same news for Tenstorrent. You didn't see the same news for Grok. Haven't heard anything similar from Sabanova. These are all companies that are out there with solutions, and so I think that effectively tells you that Cerebras has a good chip, and I think that the quality of the solution certainly matters at this point. Now, having said that, I think you look at NVIDIA. One of the reasons I think that Wall Street is underestimating NVIDIA is not only do they have a good solution set, but they also have locked up so much of the supply chain that you just can't get competition because no one can get HBM, substrate, CoWoS, go down the chain.
So now let's talk about the quality then of Jalapeno, Mustafa. I mean, if that matters so much, what are early reactions that you're hearing to how good Jalapeno might be? This is, of course, the new chip that OpenAI and Broadcom unveiled.
Yeah, I would say this is a classic example of, buy the rumor, sell the news. I think, while it's interesting to particularly hear some of the numbers of the 9 months to tape out time, which I think continues to make the kind of chip velocity really exciting for people. And as you think about electronic design automation and how do you design chips in the first place and how many chips can we have, because that velocity now is so much faster, and the tooling and the models themselves, OpenAI said, no surprise that they use the OpenAI models to help design the chip. And of course, there's a lot of companies in the private markets, including Recursive, that are helping people, from the Google DeepMind Alpha chip design solution. How do you design chips with AI? How do you make that velocity faster? So I think for me, the biggest real takeaway was around the velocity side of things. And then, of course, the timeline that they talked about as well. So we're talking about a chip that, like I mentioned earlier, has HBM in it, has eight stacks of HBM. And I'm sure over time we'll have more and more. So they're not avoiding the HBM constraint. Given they're working with Broadcom, they'll probably have leading edge TSMC capacity, and they're doing CoWoS and advanced packaging. So this is not a bottleneck optimized chip. This is a performance optimized chip. This is a chip that's tailored to the workloads that they have. And I think a lot of what we expected, maybe I expected the gigawatt size and the scale to be a little bit larger, but perhaps they're just sequencing that given, they have to kind of go through the traditional semiconductor manufacturing process.
Right. And Matt, last question for you. You cover Qualcomm. Qualcomm had their investor day this week, and they announced the acquisition of Modular, an AI startup that we've been tracking here at the Information for a little while. It was a big deal. I think it was reported to be $4 billion thereabouts. It was an all-stock transaction. My question really for you, Matt, is Modular was sort of, their specialty here was they were trying to take on CUDA, from what I recall, in terms of the software around the chips. Why do you think Qualcomm wants to get into this business, and do you think they have a chance here?
So just to preface this, I don't cover Qualcomm.
Okay.
It falls in my universe because it's hardware and semiconductor.
I read it in your note this morning, so I thought maybe it was in your coverage.
No, but I talk about everything semiconductor and hardware. So what I would say is it almost seems to me that software burden or moat that CUDA created is dissipated a bit, at least in terms of inference. Right, to some extent, it feels like a token is a token, and so I'm a little bit less certain around how much it changes the narrative for Qualcomm in the sense of just going after that token market. Now, just to speculate a bit though, it does seem like software is very important in targeting some of these world model type applications, if you will. So the automotive market or physical AI. And maybe that's what Qualcomm's looking at. I mean, certainly Qualcomm has uh, put together an impressive set of assets in terms of all the acquisitions that they've made. And I see modular as part of that. What I'm still waiting for, though, is for Qualcomm to generate substantial revenues from those acquisitions. Right, it seems like to date, Qualcomm's efforts outside of handsets have been a little bit less successful
Right.
than they've been in the handset side.
Great. Well, Matt and Mustafa, I want to thank you for coming on. That is Matt Bryson from Wedbush and Mustafa Neemuchwala from NEA here on TITV. Speaking of world models, there is an intensifying debate between world models and vision language action models, or VLAs. That debate is creating a sharp divide among tech leaders and venture capitalists over the future of robotics and physical AI. Our AI and robotics reporter, Rocket Drew, wrote about that exact topic in this morning's AI Agenda newsletter. I want to invite Rocket on to talk about it and help us understand what these terms are all about. Rocket, welcome to the show. It's great to have you back.
Hi, Akash. Great to be here.
Okay, world models and vision language action models, right? Do I have that right? VLAs.
Yep.
What are each of those? Define them.
Yeah, definitely. So a VLA is a little bit more straightforward. Let's start there. You start with a language model, like an actual language model, like the same kind that powers your favorite coding agent or a chatbot. And then you customize it, you train it on further data so that it's able to control a robot. And the hope, the idea here is that you start from a base that's already kind of intelligent. It knows how to reason. It knows how to make sense of the world and come up with plans. And you take that intelligence and then you apply it to the physical world by teaching it how to control a robot. That's kind of the vision there, okay? World models are kind of a separate approach. When we talk about a world model, really we just mean an AI model that has a really good understanding of physics. I think sometimes the lines get a little blurred here. People could say, well, ideally we'd have a VLA that has a really good understanding of physics. But in practice, people mean something kind of different when they talk about world models. They're often talking about something that was trained on a lot of video, meaning it saw a lot of videos, say like just videos collected from the internet that show people interacting with their surroundings, that show environments changing over time, and the model learns to predict the next frame of those videos, and in doing so, hopefully learns a thing or two about physics and how the world works. So, why would world models have anything to do with robotics, you might ask? Well, there's sort of two different approaches. One is that if you had this model that was really good at understanding how the physical environment is going to evolve, maybe you could just use that as the brain of the robot. You just put it in the robot's brain, you have it predict what the robot should do next, which actions it shouldn't take, how hard does it need to pick up different objects around it to move them around, that sort of thing. But short of that, even if it can't be the full brain of the robot, maybe it's too big or slow, or it only works in certain environments and not others. There's a hope that the world model could still create simulated environments. The way right now roboticists use computer simulations to train their robots, but you could have even better simulations because you're using AI to create them. So that's kind of the hope for world models right now. Does that get at the difference? Does that make sense?
I think so. Yeah. Are these approaches? You talk in your newsletter about there being a debate as to which one is, I guess, better for physical AI and for robotics. Why is it that they are so? I mean, it seems like they're trying to get the same issue. So why is it that this rift
Yeah.
even
Well,
exists?
I think the rift exists because neither of them work very well yet.
Okay.
I mean, Everyone is hoping that robotics eventually is able to scale the way like language models have been able to scale, and we can just get bigger and bigger models that are more and more capable. But robotics doesn't have access to the same kind of data that language models use, right? There's no internet worth of training data just waiting there for robotics to take and to train on. So roboticists are like painstakingly collecting more physical data to train their models with. And so far, there just hasn't been enough data for these models to work reliably. Also, they have to work really reliably, right? Because like if your chatbot that it wasn't trained on enough data and it makes a mistake or it hallucinates, I don't know, what's the worst that happens? You hallucinate a case as a lawyer and then you get in trouble with the judge. But as a robot, if you like hallucinate something that isn't there, you trip, you fall over, you break, your parts break, maybe you hurt someone nearby, and the stakes are just much higher. So roboticists are still trying to figure out what is the right way forward. If we're going to take advantage of AI for robotics, what is the right model and what are sort of the right mixes of data that we need in order to make that possible?
So, am I just to go back to the definitions here because I think it's worth actually drilling in on this. Am I right that vision language action models (VLAs) are more about collecting data from the outside world and using that data to then train the models that robots would use, whereas world models is a little bit more about using simulations as a way of sort of predicting
Yeah.
the physics of the real world? Is that the
I
idea?
think in both cases, you're going to want some data from the real world to make sure that the outputs of the model are as realistic and grounded as possible. The difference really comes down to in the VLA case, you're starting from a language model and you're hoping that your robotic model, your VLA, sort of inherits some of the intelligence and language understanding from that language model that you started with. In the world model case, you're setting out to do something different. You just want to create a model that's really good at understanding physics and predicting how the world is going to evolve. So
Hmm.
typically there, instead of language, you're starting with a lot of video data. There's a sense that, video data just sort of encodes more information about how the physical world works. Now, there's still information that's missing, right? And a lot of roboticists will harp on this. It's like when you see a video of someone picking up a glass, you don't really know how hard they have to squeeze that glass in order to pick it up. And you especially don't know if something's blocking it, if something's in the way. So video data has a lot of limitations because of these kinds of obstructions, and the force data isn't present. And some people think that that's one thing holding world models back as well.
Okay, so last question for you. I mean, in this debate here, in these two camps, who is funding each side and which one seems to be winning right now?
There's so much money going into both sides. I mean, like, I should give you some examples. Like, some VLAs are like, NVIDIA has come out with VLAs, Physical Intelligence has come out with VLAs, but also, like, there's some big names going into world models right now. Like, Fei Li's startup works on world models. The video AI companies like Luma and Runway are interested in world models, and also some robotics companies like 1X, the humanoid developer. So, it's kind of stacked on both sides here. There's a lot of prominent VCs that are funding both of them. I would say world models are a little bit on the rise right now. I think I've been hearing more and more enthusiasm for world models over the last few months, even though I don't know that world models have any sort of results to show for it yet. But my sense is there's more interest coming into the space, and VLAs haven't hit their ChatGPT moment yet. So the hype has to go
Yeah.
somewhere, and it seems like some of it is going over to world models. The last thing I should say, though, about this divide is there are other camps, right? Some people are not squarely in the VLA or world model camp. Some people are saying, well, we don't know yet. We'll have to wait and see how it plays out. Maybe it will be a totally different thing. Some roboticists came out with a position paper recently that was just called "We Need More Than World Models and VLAs." And their approach was, you guys are barking up the wrong tree. What we really need to focus on is making more data usable for robots in the first place. And there are other techniques that are being pioneered that aren't sort of like either one of these, but say using coding agents, like using Claude Code and getting Claude Code to write your robotic software for you. Some people have actually had a lot of luck with that so far, and that's different from having one physical AI brain that's meant to control your robot.
Right. Okay. Well, we do have the founder of a world models companies coming on in just a minute. Do you have any I mean, you've given us enough questions to ask him, but do you have any specific questions you'd want me to ask him?
Yeah, absolutely, absolutely. I think anytime someone's telling you about a world model, the first question you should ask is what goals you intend the world model to accomplish specifically. Because sometimes
Okay.
people play it a little fast and loose and they conflate different uses for world models, from generating videos for entertainment, like for movies, for generating advertising videos, to doing like being the brain of the robot, to being a simulated environment for the robot to train in. All this gets mixed together sometimes, but it makes a big difference what the goal is that you have in mind for your world model.
Great. Okay. Well, stick around because we're going to get the answer to that question very shortly. Rocket, I want to thank you for coming on. That is Rocket Drew, our AI and robotics reporter here at The Information. Okay, speaking of world models, Odyssey, a new AI lab focused on that technology, raised $310 million at a $1.45 billion valuation. The round was led by Natural Capital, and it has a who's who of investors participating: Amazon, AMD Ventures, Elad Gil, and Google's chief scientist, Jeff Dean. The company was founded by some of the most established leaders in the world of autonomous vehicles. I want to bring on Jeff Hawke, co-founder and CTO of Odyssey, for a conversation. Jeff, welcome to the show. It's great to have you here.
Thank you. I'm excited to be here.
Okay, so you were listening to that last segment. Our AI and robotics reporter wanted me to start off the interview with a question, which is, what exactly is your goal with the world models that you are trying to build? What is the problem that you're trying to solve?
So we're developing a foundation world model. So this is one that is trained to solve many tasks, much like you might expect from a foundational language model. And I think that's a very important point of distinction, where you need to be able to tackle this as a general problem that spans across multiple industries, including robotics. So this means from learning from all the vast information of all the different forms of data or observations of the world that you can, to learn the best possible model of reality. So these are models that learn to simulate the world.
Simulate. And so I am curious then, why did you decide to go with world models as opposed to a vision language action model then?
So they're really models sort of tackling different problems. You could think of a world model as sort of solving the sort of 18 years or so you might have of learning how the world works before you then go and learn to drive. The vision language action model, or the robot foundation model, is then your sort of driver instruction sort of at the end of that. So in many respects, you still have to have that sort of that period of learning how the world works before you then go and learn to solve a specific task.
Got it. So your models are really about, hey, collecting the data and figuring out, hey, how do we find a way to make sense of all of the nuances in the real world of data that exists?
Yeah, exactly, precisely that. So you want to see all of the crazy things that can exist, examples of giraffes and how they walk before you then encounter that with your robot.
Right. So tell me, who would be the end group of customers then that you eventually want to sell your models to?
It will be the robot foundation model companies within robotics. We do see this as a foundational technology. Again, much like LLMs, it's not just a singular industry that we expect to work with, but within robotics, it would be the robot foundation model companies.
And so those are companies like who?
Uh, I mean, all of them, frankly. Frankly, we'd rather support the industry and find ways to accelerate us towards the world of general purpose robotics.
Right. Okay. So tell me, you guys, you signed a deal with. Well, you said in your press release that AWS would be your primary cloud partner for some of the work that you're doing, and Trainium is a chip that you highlighted in your work. Why did you decide to go with Trainium?
So world models as a category of foundation model is a step beyond language models in terms of algorithmic intensity. So this means they have an enormous amount of flops that you need to put behind the problem in terms of what you're simulating. So the compute pattern is a bit different from what you might expect from an LLM in language. And as a consequence, we're very fortunate to be supported by Amazon, including being very close to their training team. And we're excited to see our workloads running on their chips.
Right. But I mean, talk a little bit about Trainium in comparison to all the other chips that are out there. I mean, this was the conversation we had earlier in the show. There are tons of options out there. You could have
There
gone
are.
with TPUs or another chip. What was it about Trainium specifically?
Um, I think it was also, I think Amazon, a range of things, frankly. I think Amazon is pursuing this very intensely as a company, and that's great for us. We want to be close to all of the chip developers. It's strategically beneficial for us to make sure that we're close to all the companies developing the best chips. So we're also very close to AMD and to NVIDIA and a range of others as well.
Right. I'm curious. So you and your co-founder, you came from the world of self-driving cars before this. What did you learn in your time working on self-driving vehicles that you are applying now to this new journey at
Mhm.
Odyssey?
Well, autonomous driving was really where sort of the frontier of AI encountered the real world, and that's really where the sort of those algorithms were matured and sort of honed as the proving ground for AI for the past 10 to 15 years. And as a consequence, it's really the industry that has learned the most about how to learn the world, frankly. And as a consequence, a lot of the lessons that we've learned in our former lives, at Wave, Cruise, and others, those transfer very naturally to building these foundational open-ended world models at Odyssey. Um, Everything from dealing with sort of the complexities of reality, dealing with photoreal data as opposed to synthetic data. There's a whole host of things that transfer very nicely.
Right. And what do you make here of just going back to the chips landscape, given that you have to consider the chips
Mhm.
that you use very closely? What do you make of all these new AI chip startups that are coming up? Is it
Mhm.
really just a matter of, hey, there's so much demand and everybody wants to get their hands on a chip, and there's a capacity shortage right now? Or does it really matter how good the chip is? And I ask this because, again, we just reported earlier this week. I mean, Samba Nova is another company here that they are raising money at a $10 billion valuation.
Yep.
There's the memory chip shortage. You just got to get your hands on a chip. How do you see this eventually playing out?
So I think we'll see a sort of a specialization to some degree. As I mentioned, the world models as a category have a very high degree of algorithmic intensity. Essentially, what this means is we push flops or matrix multiplications very hard relative to, say, the memory accesses that you would on that same chip. So there are various ways you can solve that. People sort of deploy a range of sort of GPUs or chips in parallel. That's one way to solve that. But at the same time, that is also there are decisions that could be made at the chip level that really influence how this plays out. So my expectation is that there'll be a sort of a range of chips that sort of emerge over time, including some that are increasingly capable for the type of computational workloads like ours.
Great. Well, Jeff, I want to thank you for coming on. That is Jeff Hawke, co-founder and CTO of Odyssey here on TITV. That does it for today's show. A reminder, we are on this stream Monday through Friday at 10 a.m. Pacific, 1 p.m. Eastern. If you can't make it then, episodes are available on theinformation.com, on our YouTube channel, or wherever you get your podcasts. Make sure to follow us on social media, on X, on Instagram, and on TikTok. I am already excited for our next show tomorrow. Have a great rest of your Thursday. Bye-bye for now.